Alright, so in the previous lesson, we sort of did an introduction to electrochemical cells, and we saw a very short an animation on voltaic cells. Um, this is a diagram from a past Regents exam, and this will give us a chance to kind of practice what to do with a voltaic cell. So let's go through this one, and you should be able to do this with any voltaic cell. First of all, you're going to notice that it has two containers. That's an indication that it has a voltaic cell. Also, it has a salt bridge. That only occurs, again, in a voltaic cell. So this is two ways to differentiate between the galvanic or voltaic cell, which are the same thing, and the other electrolytic cell. And we'll get into that later on. So let's quickly run through this. So first is this. We have, all they give us are the two electrodes. That's lead, and that is silver. We have to be able to figure out where the oxidation and the reduction is occurring. So we're going to need to look at Table J. Table J says that Pb is above silver. So since Pb is above silver, this is going to be the anode, and this is going to be the cathode. And remember, red cat, anox, red cat, and ox, which means that oxidation is occurring here, and reduction is occurring here. So once you've determined that this oxidation is here, you know first of all that the electrons are going to travel from here to here. So the electrons are going to go from here to here. So you're going to draw an arrow sometimes in this direction. The electrons are going here. Now, is the oxidation always on the left side? No, it could very well. If I had put the silver here and the lead here, it would be going in the opposite direction. So it's not always going to be from left to right. Also remember that the salt bridge has nothing to do with the electrons. Okay, let's move this up and see what we have here. Now, question number 2, we are not going to worry about what the negative electrode is and what the positive electrode. You only need to worry about where the oxidation and reduction is occurring. Oxidation at the anode, reduction is at the cathode. So if you look at it, it says at which electrode or in which half cell does the reduction occur? Well, the reduction is occurring, you can write it a couple different ways. You could say it's occurring in half cell number 2, or you could say it's occurring at the Ag electrode or on the right hand side. The electrode where oxidation is occurring is either half cell 1 or where the Pb is, or on the left side. That's simple. Okay. Which electrode is the cathode? Well, we already know that. The cathode is going to be the Pb. I'm sorry. Hello. So the cathode is where the reduction occurs. That's the Ag with a 0. The electrode is the Pb with a 0. Okay? And that's an example of a typical reaction. And that's the end of this unit. It's very simple. That's what you have to be able to do with, a couple of other things. Since we're here, I might as well do that. One of the things, and they should really have this on there, you should be able to tell which electrode gets larger and which gets smaller. So the electrode where oxidation occurs, which is the anode, always ends up getting smaller in size. Okay, and you should write this in there. The anode, which is where oxidation occurs, gets smaller. I don't know why it's doing that. I think you get the idea. The anode gets smaller, which is this one here. The electrode, that's the cathode, where reduction occurs, always gets larger in size. And you saw that from the video that we did before. So that's the end of this.